Hi. Last night I did a video showing the moon rising to the east-northeast, and it was a waning gibbous, and it seemed to be pointing into the ground. And so I challenged the flat Earth hypothesis and said that either the moon is larger than the sun and much further away than the sun, somewhere above the sun, and that the sun is still going to was rising in the east, or that the moon is self-luminescent. There's already a problem with that too. The moon would have to be self-luminescent because the sun would have been somewhere to our north still, because it would have not have gone all the way around the Earth on a flat terrestrial plane. So we would have had to have concluded that the moon is self-luminescent, and it just looks like there's light shining off the moon. Or that the light source is invisible somehow and we can't see it ever. So now this is about 11 hours later or 12 hours later, and so the sun is high in the sky at about a 45 or 50 degree angle to the southeast, and the moon is to my west-northwest at about a, I don't know, I would guess like a 30 degree angle or 35 degree angle. But the angle formed between the sun and the moon is about 90 degrees, and the moon is almost a half moon, which is what it would be expected if I'm the vertex in angle between the sun and the moon, and the moon is at half phase, then it's going to be about a 90 degree angle. And I'll show you that that's actually what it is too. So looking to the south and then looking up at the sun using this X-ray film, you can see the sun. The intensity of the sun does kind of change its apparent size because of the focus on this camera. So to narrow down exactly what size it is, it's kind of difficult. I guess maybe holding it really far away is probably the right way. But that's our sun. It probably takes up the same 0.533 degrees in the sky as it usually does, which is about the same as it is on the horizon when it's very late rising. So it seems like the sun never gets any closer to us, which you would expect if it was 93 million miles away and we only slightly change our distance in orbit from it, and if we're just rotating. Alright, so that's the sun. The moon is hard to see in this display, but it should be right in front of us. Oh, there it is. Okay, so there's the moon. Let's see what that phase looks like now. It's just over a half phased moon. So it's still a waning gibbous, but it's pretty much a half moon. Okay, now I'm going to zoom out. We're going to look at the angle that the sun and that moon make. This is about a 90 degree angle, right? The corner is. So if this is pointing towards the moon, that means that the other perpendicular side of this is pointing towards about the sun. And let's see if it's kind of hard to show that because of the way I'm holding my phone. But here, let me hold my phone a different way here real quick. Okay. So this is pointing towards the moon. If I just rotate this, that's pointed towards the sun. So it seems that the moon is pointed towards the sun, and that's because the sun is reflecting off of the moon. You notice that this phase is actually pointed towards like the southeast, where the sun is now, whereas 12 hours ago or so it was pointed down into the horizon. So it's almost as if it was just moved like this, and it rotated with its movement. If that's the same face of the moon, we've just rotated is all we've done. Not only that, but if the moon is self-luminescent, then somehow areas in the Pacific, they can't see the same phase of the moon, can they? How could they do that? So areas far west of here are going to see it closer to the sun, right? and they're going to see more of a crescent shape. They're seeing more of the dark side of the moon. If the altitude of the moon is insignificant compared to distances on the globe or their circular path around a flat terrestrial Earth, the phase of the moon is not going to be the same for everybody. Now, I mean, I'd like to believe in a Shawncentric model. So, you know, whatever city I live in, that's what dictates that the moon stays the same phase, because it's all revolves around me, right? I mean, if we believe that, then that's why the moon is this phase. I don't know what it is where you live right now, and it also stays the same size for me. So the moon actually gets a little smaller, you know, as it gets over the horizon. It starts to shrink. It's like a balloon, you know? So when it's above me, it deflates, and then when it moves further away, it inflates. So I don't know how big that moon looks to other people, like directly underneath it then, if the flat Earth model is right. It's probably a little bit bigger. In fact, it's probably eclipsing somebody. It's a pretty big moon, right? I don't know. So to me, I mean, just looking at the relative size of these objects and how they don't change, stays about the same size. In fact, it's the same size as the moon approximately, which is a weird coincidence in astronomy, I have to admit that. So what does this tell us? This tells us that we just rotate. They stay in their fixed positions approximately over a small unit of time. The sun does not gain on the moon, and they don't go in a circle around the globe. The moon is not self-luminescent. It points towards the sun. Its phase, it doesn't just, I mean, it wasn't a full moon when it went over us, but it was still pointing at the ground before. So if it is self-luminescent, somehow it's rotating in a Shawncentric model and always showing me the same phase. If you have other footage showing a different phase right now, I'd be really interested in seeing it. Alright, well, I hope you enjoyed this video. Feel free to comment and challenge what I said here if you have any comments. Alright, bye.